Good evening, I'm just resetting my little board. Today I'm doing some assembly code, which is hardcore computer code, which is the lowest level computer code you can do, apart from machine code, which is typing in binary zeros and ones, which no one apart from a computer itself should endeavour to try. Excuse me, I'm just getting this out of the way. I'm just what this is. I've got a little board here called an Arduino, which is a experimenter hobbyist project testing board platform. It's a little board which you can load software with and make it do things. There's pins that go to the outside world. You can program them to read and write and do data analysis and stuff. Anyway, this little board, I've programmed it with a little bit of software called MOUSE2go, mouse number 2, G-O. That's the name of the project, and it emulates a 6502 processor. Now, a 6502 processor is the heart and the brains of the BBC Micro from the 80s, and also the NES, Nintendo Entertainment System games console from the 80s, 90s. And this little chip has got some software inside which pretends to be that. The chip on the board, the Arduino, is pretending to be this other chip from the 80s. I know, it's convoluted, isn't it? If you're not, it's quite abstract. Anyway, what I'm doing, I'm writing some software at the lowest possible level, which is assembly code. As I say, it's one step up from binary, but it's as low as a lower level. It's as lower level as a human being wants to get in writing software. If you can write assembly code, you're doing well, because that's the lowest you can get. Excuse me. If you write JavaScript, if you write C, if you write Visual Studio, it's all built up much higher level, many layers up from this machine code, this assembly code. So what I'm doing now, I'm just wondering what that noise is outside. What is that? Sorry guys. Oh, it's an aeroplane. Anyway, but what I'm doing now, I'm dumping the memory from address hexadecimal, which is, don't ask me to explain that right now, 0400, 10 rows, 10 columns, and you see it's empty, it's all zeros, okay? Now if I reset it again, now then, if I do assemble 0400, I'm telling the software I want to start writing some code, starting at the address in memory 0400. So my first instruction is immediate OA. LDA means load accumulator. Accumulator is a register in memory. I'm not at all au fait with a 6502 microprocessor yet, so I don't quite know what I'm doing, but I'm just following some code I found on YouTube, which is always a good place to start. JSR E03. You'll see after me typing all this code in, you'll see what it does. You'll see it says 0400 and underneath that 0402, then 0405. It's basically incrementing itself automatically. I don't quite know how or why, but it does. Anyway, I don't need to overanalyze it too much, otherwise I'll get confused. Small steps, baby steps. LD. What's the other one called? Sorry guys, 2 secs. Gotta check something out. LDA 41. Yes, LDX 1A. JSR, which means jump to subroutine, E03. Yeah, ADC, immediate 01. DEX. Hey Google, what does the assembly code DEX mean?
Real mode. On the website stackoverflow.com, they say, so for instance, DSDX means in 16-bit real mode to access the 16-bit value in the DX register offset from the DS segment value, which increments in 16-byte values.
That could be wrong, because Google doesn't always understand exactly what you're asking it. Sometimes it gives you very random. That could be completely wrong. I think I'll Google it properly later on. So DEX, who knows what that means? Branch if not equal, I know what that means. BNE. See, all these codes, these mnemonic codes, these 3-letter instructions are written to sound as humanly relatable as possible, without being more than 3 letters long. JMP jump E094. Oops. We'll start again now. Never mind. Never mind. It's all good fun. We'll start again. Assemble. We'll start again. Got to start again. Assemble. Okay, LDA. I know this code off by heart after tonight. Hash O8. Jump to subroutine. E03. LDA hash 41. Hash 40. Oops, did it again. Forget it. Game over. Reset again. Reset again. Let's try again. Practice makes perfect. Assemble from A400 address onwards. Yep. Hash jump subroutine E03 LDA hash 41, which is immediate 41. I'm reading this out as I'm doing it, because as you read things out, they become embedded in your brain. If your psyche, your brain knows you're saying it out, and your voice is going back into your ears, it's going into your brain, it's reinforcing the learning cycle. Do you know what I mean? Like if you read a book out, the Bible or something, as you're reading it out, you're speaking it into existence by talking it, and the words you're saying are going back into your brain and being like absorbed around again and again. Anyway, that's how I see it. LDX. JSR E003. ADC. Hash 01. DEX. That's the one I didn't know what it meant, wasn't it? BNE. Branch not equal. 0409. JMP jump. E094. Now it's waiting for the next line of input, which I don't give it because I've finished that. Press escape. Now press go. 0400. And that's all this code here. All this code here is telling the computer, the chip, to output the alphabet on one line. Yeah. So yeah, what can I tell you? That's what I've been doing. I've got to go away now and figure out what these things are doing, how it's working, this program. That's the fun part, to take it apart and see what it's doing. LDA means load the accumulator A, or with this immediate value, which is hexadecimal 0A. Jump to subroutine, jumps the code somewhere else, etc, etc. Anyway, that's enough for tonight. I've confused myself a tiny bit, not as bad as last night, but a little bit. And yeah, I'm getting this code from a YouTube video, someone who made this software, so it's all good fun. Thank you, God bless you, good night and goodbye, or good afternoon or whatever. See you guys.